Geometrical meaning of the zeros of a polynomial. Case 1 in case of quadratic polynomial is the graph cuts x-axis at two different points a and a dash. Hence there are two zeros. In case 2, the x-axis of the graph cuts exactly at one point. So a and a dash coincide and we get only one zero. In case of third case, the x-axis graph is either completely above or below the x-axis, hence it does not intersect or cut the x-axis, so there are no zeros. So from this we can conclude that the shape of the curves are either completely open upwards or completely open downwards, hence these are either a greater than 0 or a less than 0, and these curves are called as parabolas. Next, in case of linear polynomial, the graph is of the form y equal to ax plus b and its points are minus b by a comma 0, and it has only one zero. And in case of relationship, there are two relationships in case of quadratic polynomial. One is sum of zeros, which is equal to minus times coefficient of x by coefficient of x square, and product of zeros, it is equal to constant term by coefficient of x square. So in general, if alpha and beta are zeros of the quadratic polynomial p of x, we can write simply it is equal to k times x square minus k times alpha plus beta into x plus k times alpha beta, where k is a constant term, alpha plus beta is sum of zeros, and alpha times beta is product of zeros. Alpha plus beta is nothing but minus b by a, and alpha beta is equal to c by a. In case of cubic polynomial, it applies the same. Here, instead of two zeros, there are three zeros at maximum, and relationship is sum of zeros. It is nothing but minus time coefficient of x square divided by coefficient of x square, and product of zeros is minus of constant term divided by coefficient of x cube, and there is a third relationship which is nothing but sum of product of zeros taken two at a time, which is equal to coefficient of x divided by coefficient of x cube. So in general I have mentioned below. Thank you.